This is to look at the subarray sum problem as two typical questions of 523 subarray sum problem as a multiple of k or subarray sum as exactly equals to k. When the problem has a multiple of k, we get a series of numbers. Want to find is there any subarrays that is a multiple of k. This is a typical problem we're using hash map to identify where is a subarea of multiple of k. And the trick of this is always to find the delta. Similar with 560 as well, using the prefix sum and to check the subarray sum by checking the delta. So it is a bit of abstract to talk about this, but let's start looking into the code. Actually, before looking to the code, which quickly describing what we mean by delta. So there is an array 1 to finding the prefix sum, which is going to be a cumulative number to picking each of the numbers from the array as added up. And for each of the number as a cumulative number, we're using k as the divider to find the remainder. And once the remainder is the same, once we find a clash, say 23, 2, and 4, when we're finding a clash using a reminder as the same reminder, then we know the delta between these two, when the k is 6, this 23's reminder on k on 6 will be equals to 29 on the 6th reminder. That means the delta from 2 and 4 adding up will be the exact multiple of k. So this is a concept of finding delta. Similar with subarray sum, we're also doing the delta calculation. As how we're finding the prefix sum is when we keep calculating a number from each of the number picking up from the array. Once we find a match from, because the accumulated number is always going to be increasing. It's going to be ascending order. Once we find the prefix match is a 1, then we try and find where is a smaller number that we find. Because by the increase number, we find it's exactly matching to the previous sum we have been finding too. Then we will know this delta adding from any of the subarray we have been added will be equal to the exact sum we're looking at as a k. K here is a 3. As we go through 1 to 3, the 1 and 2 add up together will be 3, and then plus another 3 will be 6. But once we're finding the previously finding the 3, the 1 and 2 will be another 1. So 1 plus 1 will be 2. So let's look into the code. So looking into 523 as a solution, pretty simple. Start with a map and start accumulating the prefix sum as travels through each of the number. Well, the key part is about getting the reminder, using this reminder as a key. Firstly, we're checking if the key existing in the map or not. If it's not, we're just simply putting the reminder in as a key and put that index into it, reminding what this index will be logged as a reminder. And this is a baseline setting. The -1 does not mean anything since we haven't traveled through any number. We should want to make sure the 0 as a starting point will have the -1 as a baseline. But once we find the reminder, it means in this map I have recorded the same reminder before, then we know there will be a previous index that is using the same reminder as the current I has been using the same reminder on this. The delta between previous index and I is definitely a multiple of k because they're both molded by k. And we just need to check whether this index has enough gaps that's bigger or equals to 2. If it's bigger or equals to 2, then we find a match. If it's not, we just keep going. That's a pretty straightforward as a subarray sum. But once we go to the 560, that problem is quite similar. Before we travel through the array, we set the baseline as number 1 because we're finding putting the sum of nothing, we have occurred at number 1 position. That's just baseline setting, does not mean anything, but when we're going to travel through the numbers inside the array, we can accumulate the prefix sum, and we want to find out the prefix sum minus k, whether we have found it or not. And if this hasn't been found, then we know this is not existing, then the result should not be bumped because it's default to 0. But if we find one that has prefix minus k as 0, which means the prefix is exactly to 0 now, this means we will have find 1. We're using this baseline as finding 1, the results would get bumped up by 1. Once we bump up the results, we would keep accumulating the prefix sum into the previous existing prefix sum plus 1. This is quite important, as if we ignore the prefix sum, it will lose accumulation of the previous sum. Maybe the number get changed, or maybe the number get fluctuated, or there's a 0 repeated. But based on the previous we find, we see another occurrence, and 1 has been appearing. And once this 1 has been appearing, we know the prefix sum of this has been showing before. But since the prefix sum has been keep accumulating, once the number has been increased, and once the number has been finding further as the prefix sum has been increasing, once we go back to prefix sum minus k, we will actually traverse back to see what the other possible numbers we have seen or not. In this case, if this prefix sum minus k has been found and results, that means this number has been in previous iteration, the number, whatever this is, has been recorded as occurrence before, then we know the results need to be bumped further because we find another subarray inside this array that is exactly matching to k. From the previous finding to this finding, the delta between these two arrays is exactly equal to k. That's the beauty of finding the delta through the accumulated array as a prefix sum. And then later on we'll find what is the map results, and we'll find out what is the result we have been accumulating so far as a cumulative array we have been finding. Yep, that's debugging error message. As we can see, when we're going through a random array, going through like this, 321, 6, 3211, we have seen the array has been accumulating. And strangely, we're finding all this number has been accumulating, but once we find a 3, this number will keep getting used, and 6, it will keep getting used to find out exactly where it has been existing before. Yeah, that's the end of the demo.